All right, hello once again, Jeff Scott of Rankin Technical College, and as part of the Rankin Technical College AWD, or Application and Website Development 1100 C# Programming online course for the summer of 2023, I've decided to do a couple kind of intro-like videos um, introducing some of the stuff in the book to the class. So far, I've done the first 3 chapters and the appendix at the end of the book. So let's go into chapter 4 now, which is entitled How to Work with Numeric and String Data. So you can see how to work with built-in values, how to work with strings, how to convert data types, 4 other skills for working with data in 2 versions of the Invoice Total app. So it looks like we're going to enhance it, which is fine. All right. So your built-in data types in C# are shown right here. And let me just say, if we count these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 data types. And let's be real here. Now, personally, I think that the byte data type could very well be used a lot more than it is, which is almost never. But if you were talking about, for example, people's ages, 0 to 255 makes a lot more sense to me than working in the thousands or the billions. But, it's fine. So the ones that you'll probably use the most often in here will be 5 of them. Int, which is a whole number, -2 billion plus to +2 billion plus. Double, which is a decimal or can contain a decimal. All right, decimal itself. So int, double, decimal, char, which is a single character, and bool, which is a true-false. And we'll look at all of them. All right? You can kind of look at a variable as being like a box. It holds something. Now, what is different in C# as opposed to those of you who are in JavaScript? Now, in JavaScript, we would do something like this. Now, I'm going to show you something I probably shouldn't right now, but it's okay. And I'm going to go back to this monthly investment thing we did a while ago. All right, and I'm going to just go to the calculate. There's nothing in there right now, but I'm going to add a variable. Now, when we were working with JavaScript, we would say let, and notice there is no let here. Doesn't know what I mean. We could say var, and we can still use var. And we'd say like var age equal 21. Okay? And we can do that. We still can. However, in JavaScript, if you did that later, you could say age equal 10. And notice now the system is complaining. Because once you declare a variable to be of a certain type, you can't change that type. So I can't say like int age equal 21 and then later on say age equal false. That doesn't make sense to the system. And I'm going to get an error that says cannot implicitly convert type bool to type int or into whatever. All right, you can't go back and forth. So, these are, I'm going to show you, like I said, there were typically 5 variables. And I would, if I could, for example, I could say this. I could either say double salary equal, and let's say the person makes $123,456.78. Totally fine. Or I can say decimal salary equal 123,456.78. But then I need to put a letter M in there. All right. And this could be, let's call this DBL salary. So that's a double salary. And we'll call this DEC salary. Okay? So it's okay to do that. All right, I can do those. Now, let's say I had an int. If I have int, I can't say int salary equal, and now I cannot say 123,456.78. I get an error. All right? And it's going to tell me cannot implicitly convert a double to an int. But I can do this. get rid of any decimal portion, then that's okay. All right. I can work with a string, and I can say first name equal Jeff. That'll work just fine. I can grab just a single character. How about we'll call this middle initial? Just middle init. But then, since it's a char, it has to be a single character. And it has to be within single quotes. All right. And then the bool, okay, so those are examples of each one of the variable types. Now, when you look at these, the reason that I'm getting all these underlines here is what it's telling me is you've got this variable here that you've declared, but you're not using it for anything. And I don't understand what it is you're trying to do. So these are not errors right here. These are just warnings. All right. If I come down here now and I say, for example, I don't know, double salary equal double salary plus int salary, then now notice they're not gray anymore because they are being used. Or if I said minus int salary, etc. All right? I'm just showing you a couple things as we're going on in here. So a variable literally holds a value. You've got your choice when you declare a variable. You can do it over 2 lines. This right here, int counter, that is declaring a variable. This right there is assigning a value to a variable. If you know the value of the variable when you create it, you can both declare and initialize it in the same line of code. All right, sometimes you will know that, sometimes you won't. Now, as it says there, a variable stores a value that can change or vary as a program executes. All right, before you can use the variable, you have to declare it and give it an initial value. All right, common initial values are 0 for integers, 0.0 for decimal or double, the empty string for a string value, false for a Boolean, etc. Let's see. When you use floats, they need to have a big uppercase or lowercase f at the end of them, just like we saw with decimal types needed an upper or lowercase m. Some naming conventions: start the names of variables with a lowercase, and then if you run words together like tax rate, have it a little lowercase tax, capital R, lowercase ate. That's called camel case notation. Try to use meaningful names. Your program will be more self-documenting that way. You can also create constants. Now, you don't have to do this, and they don't do it here, but in many languages, when you are showing a constant, you put it all in capital letters. So for instance, I'll keep all these here, but let's create a constant, and I'm going to call this inches in a foot, and I'll set that equal to 12. Now it doesn't like it because I didn't let it know what type of value is in there. But if I say const int, everything's hunky-dory. And you can make constants of type double, of type decimal, of type int, of type string, etc. Virtually everything that's in here. All right. Now, the way that they do it in the book here is they do it more like this. All right, which is totally okay, but To me, when you make everything capitalized like that, it really shows anybody else, hey, that's a constant, don't monkey with it. That's the way I was taught. Arithmetic expressions, well, some of these you already know. All right. The first four that are there, you should be very familiar with: addition, subtraction, multiplication, and division. Modulus is the remainder operator. Two times modulus is used quite a bit. One is if you've got a number of seconds and you're trying to convert those into a number of hours, followed by a number of minutes, followed by a number of seconds. All right. The other place where you might end up using modulo quite a bit is when you're working with dollars and cents. It's a remainder operator. You can put a plus sign before a number, meaning that it's positive, but if you leave it off, it's implied that it's positive. You can put a minus sign in front of a number, meaning it's negative. And then there's a plus plus and a minus minus. Now, the plus plus and the minus minus sometimes confuse people. There are examples here, but let's just take a look at an example in our code here. All right, so I'm going to remove, in fact, let's just comment out all these. Okay. All right. So if I come in here and I do this, I'm going to say int x equals 27. Int y equals plus plus x. All right. There is a difference between saying this and saying int, I got to give it another variable. So I'll give it z equals x plus plus. There is a difference between those. This is called the increment and assign operator. This is called the assign and increment operator. Let's get rid of this and just run these both ways. If I do this, the plus plus means add 1. So this is going to go and add 1 to x, making it 28. And then it's going to take the 28 and assign it to y. So when we get done with this, x equal 28, y equal 28. All right? It is called the pre-increment operator. And you can use minus minus as well to remove one. Now let's do this again. And let me grab this. And now let's use the post increment operator. So we're going to say x plus plus. This is the post increment operator. Again, what does that mean? That means that now when we get done, it means first take the value of x, which is 27, and assign it to y. Then add 1 to x. So in other words, when we're done, x equals 27, y equals, I did it backwards. Take the value of x and assign it to y. So y is equal to 27. Then add 1 to x. So x is equal to 28. Now that may take a little bit of time to wrap yourself around there, but typically you're going to use this the most when you are working with loops. And if you say, I don't know what a loop is, you're going to learn that in a future chapter. All right? If that confuses you, then don't use it. All right? It's just meant to make it a little bit easier for you. Now, they mention here, these things here, those are called binary operators. That means there has to be a number on one side or an expression and a number on the other side or an expression. These two things, in fact, these four things, are unary operators. So there's either a number right after them or a number right before them. All right. Now, most people, if I ask you to read something like this, you're going to say counter equals 7. That's the way I would read it. All right. technically, that's not what that means. Technically, that line right there means take 7 and assign it to the variable counter. People just don't talk like that. All right, so you'd say counter equals 7. But really what it means is it's an assignment operator. All right? And notice there's also some other operators that you can use along with this. This gets confusing. All right, so I'm going to come back to my example here. All right, and we'll keep x at 27. Okay, and now, in fact, let's do this. I'm going to just comment this out. Okay, but now let's come in here. We've got x equal 27, and let's do this. X plus equal 30. Okay, that's a shortcut. That is a shortcut for you saying this x plus equal 30 is a shortcut for you saying x equal x plus 30. Okay? This would be a shortcut for saying x equal x minus 30. Get rid of that plus sign. This would be a shortcut for saying x equals x times 30. This would be a shortcut for saying x equals x divided by 30. And this would be a shortcut for saying x equals x modulo 30. So they're just shortcut operators. All right? Again, if it confuses you to do this, then write it like this. It's totally fine. Especially if this is your first programming class, you should be programming for understandability on your part. As you go on and you're in your second year, especially in your last semester, you should start writing more professional looking code. All right? And it's not that writing it as 2 lines is it's not professional. It's just it's easier to write it as 1 line. When you work with this stuff, this is your order of precedence. You do that plus plus and minus minus first. Then you do the positive and negative, the plus sign or the minus sign. Then on the same level are multiplication, division, and modulus, again, the remainder operator. And then finally, fourth is addition and subtraction. You can always override that by using parentheses. And that's what it says in here. Casting is a little bit confusing, so let's take a look at how that's used. I'm not going to use their examples in here, all right? But I do want you to see this, okay? So if I go in here and I do this, whoops. All right, so if I come in here and do this, I'm going to, again, just comment out these examples. Remember our comment operator? So I can highlight all of these and then click over here. All right, now they're all commented out. All right. Let's see. If I say this, int x equal 27, double y equal, let's make it 3.14159, make it pi, basically. I cannot do this. I cannot say x equal y. That's illegal because I'm trying to take a double and assign it to an integer. I can do this and say y equal x. I won't get any error or anything there. That's legal. But what if I want to take this value right here and just take the 3 and assign it. Well, I cannot do this, x equal y. I'll get an error. But I can say, take x and grab me the integer portion of y. That's going to take 3, and it's going to assign it to x. That's legal to do. So when you want something, see, I'm not changing the value of y. How do I know that? Because the value of y is appearing on the right-hand side of an equal sign. You can only change something in here if it's on the left-hand side of an equal sign, and this is not. Sorry. All right. Okay. Now, there's something that's built into most programming languages that's called the math class. And it's got a bunch of built-in stuff. Notice you can round numbers, you can put something to a power, you can get the square root, you can get the biggest or smallest number, and there's several examples here. I'm not going to read any of them, but they're kind of cool. Let's write, just so you see it, okay? Let's write a real simple program. Now, you may or may not agree that this is a simple program, but let's try to see if we can write one here. So I'm going to come back to here, and you may not know this yet because I hadn't explained it, but right here, I can go and add another project to my solution. So I've got this thing called test project, okay, and that's right here, but I'm going to right mouse click on my solution, and I'm going to choose add new project. It's again going to be the same kind of project we've been working with. In other words, it's going to be a Windows form project, all right, with a .NET framework right there. Notice I don't have to tell it where it lives. It already knows it lives inside of this test project solution. But I'm going to make this and call it test project 2. Okay? All right, now this is going to be a really simple, in fact, let's do this. Well, we'll do it the way I'm showing it to you right now. Okay? And all I'm going to do is just very simply this. I'm going to have a label. I'm literally doing this off the top of my head. So I'm going to label right there. I'm going to have a text box. And a text box. Why am I not finding a text box? There it is. That'll be right there. I'm going to have a couple buttons. All right. And I'm going to have to pause this meeting because I forgot we have a meeting at noon. So just for now, I'm going to kill that. But I'm going to put in 2 buttons here. I could put in 3 and have an exit button. I don't care. But I'm just going to put in a couple buttons here. This is going to be a calculate button and a clear button. I'm going to make these both nice and big in just a second. So this is going to say, this will be LBL RN. I'll just call it random. LBL random number. And the text will be literally random number. All right. And this right here is going to hold the random number. So this will be TXT random number. All right. This will be BTN calculate. And it'll say calculate. And this will be BTN clear. And it'll say clear. All right, I'm going to go make these all bigger as far as their text size. So I'm going to make these nice and big. And we'll make these 28 bold and Arial. All right, don't worry, I'll make, oops. These two are fine. There's my random number, and I spelled random wrong, but we'll fix that right now. There, and I'm going to make this bigger. That should work. All right. It's not a pretty interface, but it's functional. It's all I care about. Okay. Now, the thing is, when I click calculate, I want it to put a random number in there between 1 and 100. When I click clear, I want this to be cleared. Okay, pretty simple. So this will be txt random number dot text equals double quote txt random number dot focus. That should be it for this. So I should be able to come in here now. Oops, and I got to tell it I want it to run this project. So set a start a project. There it is. So if I can put anything I want in here and click clear, and my cursor's there too. So that worked. All right. So we want to come in and we want to make a random number there. So let's look at how to do that. All right. And there shows rounding, power, and stuff, but somewhere in here will be the random number. Here you go. How to generate random numbers. So we can say random number equals new random, just like that, and then do a number. We're going to just follow what's in the book here. So I'm going to grab 2 lines from here. I'm going to say random number equals new random. That's going to create a new instance of a random number class. And then I'm going to say number dot next, okay, 101. Okay. All right. So let's put these in. Okay. And I'm going to come in here and say, oh, that's in clear. So in my calculate routine, I'm going to come in there and do that. Let's run this and see what happens. All right, I click calculate. Oh, I forgot to tell it to put it in there. So let me do that. txt random number dot text equals number dot toString. Good. So let's do that. All right. Whoa, that didn't work, did it? Well, we'll get it to work. I have to go to my meeting in just a minute, so next. Straight. Well, it didn't like that. It's giving me system.rand here, which of course we wouldn't want. Random number equals no random number dot next 101. Thought I was following what was in the book here. Random. Okay, we'll do it like that. All right, let's look at that, and then I got to leave from my, I'm going to pause for a moment. Notice I'm now generating random numbers between 1 and 100. So I'm going to stop for a minute. We'll come back and we'll dissect this program after my meeting ends. Okay. All right, so my meeting ended, and let's pick this back up. So what we've done here is we created a variable called the number. All right, this is something that's going to be more that we're going to get into in chapter 12, but this is instantiating or creating a new instance of the random number class called number. All right, and we are taking that instance and running the next function. So this is going to end up basically creating a random number between 0 and 100, which we are assigning to the number, and then we're printing it out. So as you can see, when I run this, if I keep calculating, I should keep getting a number that is between 0 and 100. Now I could pretty this up just a tad here and come back into my form and center this, which would look a little nicer, I guess. Okay, so all right, so that's pretty much it for that one. Let's see. So there's examples here of using random numbers, just like on the previous pages. There were examples of, well, I guess I don't have it up here anymore. There were previous examples of using the some of the functions, those being like the next, all right, etc. But before that, there were examples in here of using the math pow, math round, etc. So math is what's called a static class, which means it has static methods in it, which means you don't have to create an instance of the math class to be able to use its methods. Just say math dot something. And again, this is done very well as far as the description here. And we'll take a look at some of this as we go on in the semester. Strings, unlike JavaScript, strings in C# can only be within double quotes. If you use single quotes, all right, it's a character, a char, a single character. Now, if you want to go and basically clear something out, what I've been showing you in here has been doing this. Text.number equals, and that's totally fine. You can also say text random number dot text equal, and there's something called string dot empty. I don't think that is I think it's just like that. You can use that as well, but you can see it's a lot less typing to just do the double quotes, but you'll see them both in actual application in practice. Okay. All right. Here they show an example and they're using a capital S. This is always a big thing. A string, as it says, can consist of any letters, numbers, or characters. It has, by default, a string has no mathematical value. All right? You can give it a mathematical value if it holds a number, but by default, it doesn't have a mathematical value. You can also set a string equal to null. There are several different methods you can use on strings. All right, I should mention this right now that if I go out to docs.microsoft.com, docs.microsoft.com, this is kind of, if I come in here and I say, for example, to search C# string methods, all right, if I put that in and hit enter, how to search strings, how to modify string contents, how to compare strings. All right, notice there's tons of stuff in here on strings. All right, this is a great first place to start. Now, I went to docs.microsoft.com. It's, I guess, been changed to learn.microsoft.com, but either one of them is going to get you there. All right. How to put special characters into strings. This won't be that big a thing until we actually go in and look at files and some other stuff. Now, these are what are known as escape sequences. Out of the ones that are in there, the two you will predominantly use, probably over 90% of the time, are the \n, same way we used it in JavaScript for a new line, and \t for a tab. Once we get into talking about files and the like, you may end up using the \\. All right? Okay. Raw string literals. All right? I have never used anything like this that's got 3 double quotes in it and ends with 3 double quotes. But evidently, when you use that, you can create something and put it over multiple lines. So as it says, a raw string literal can contain standard text characters, white space, and special characters, typically used for lengthy strings of formatted text. Never used it before. Interesting that they have it available. All right, how to convert data types. All right. The .NET structures and classes that define data types. Okay. We will end up using some of these things in here. Some of them, believe it or not, we've already looked at least somewhat, like the decimal.try, like 2parse, or with try parse, etc. It's similar. But notice that if you want to make something a byte, all right, you use byte with a lowercase b. So these are the ones that we use. And as I mentioned, int, double, decimal, bool, and char will be the ones you use most often from this list, and string. So as mentioned here, each built-in data type is supported by a structure or class within the .NET framework. All right, this thing about structures and classes, let's hold off on that until we get to the Chapter 12 area. All right, how to use methods to convert data types. Some of these you've already seen. I've shown you the try parse, all right, the toString, etc. We've looked a little at those. And let me mention too that the first day of class, we're going to go in, we're going to build anywhere between 2 and 4 programs, depending on how much time we have, and they're going to be remarkably simple. But they will allow us to look at some of the stuff that's in here as far as converting and the like. And as the semester goes on, you will be using toString a lot. You will be using try parse quite a bit, etc. So you'll be using those things that are in there. There are plenty of string methods. Okay, this is formatting codes. You've already looked at the currency, which can again be an uppercase C or a lowercase c. We've already looked at the %, which is again an uppercase P or a lowercase p. The only one that's in here, the only other one that I ever use is the N. All right, if I want to make sure something is a number to a certain number of decimal places. And again, they have some examples in here as well. Now this string format, this looks a little funky. All right. There are different ways that you can format things. If you remember, we used the backtick or backticks to create a template literal in JavaScript. There is something similar to that in C#. I'm going to hold off on it until the author gets into it. All right. Scope of variables, where you declare something is where you can access it. What does that mean? That means that if I declare something outside of any routine like this, it has class scope. What does that mean? That means you can use it anywhere and not have to pass it anywhere in the class and just use it. These variables have method scope, so they're only known within this method unless we pass them to another method. So as they mention here, the scope of a variable determines what code can access it. If you try to refer to a variable outside of its scope, you'll get an error. If you declare a variable within a method, It has method scope if you declare it within a class, but not within a method. It has class scope. The lifetime of a variable is the period of time it's available for use. A variable with method scope is only available while the method executes. A variable with class scope is available while the class is instantiated, so as long as the class is active. Enumerations, also known as enums, are typically used if you want to go in and create your own variable. So here we're creating a new variable called terms. And the values of this, now by default, these values are going to be 0, 1, and 2. So it's as though you said net 30 days equals 0, net 60 days equal 1, net 90 days equal 2. But what you can do, as they show right here, is instead of setting it up like that, you can actually give them values. All right, if you want to do that. There's a lot of ways, believe it or not, in which this can be used. All right? It just depends on what it is you're trying to do. Now, probably the hardest thing we've had so far has been this next section, and that's working with nullable value types and null coalescing operators. If you declare something with a question mark after you declare it, all right, basically what that says is that it can hold a null value. So if we look in here and we look at some of these examples, let's see. Here, these right here are saying that it is possible sales 1 could hold a null value. All right, typically you will use this question mark with numeric values, and with numeric values, if you give them a value of null, at least at times, the program will blow up, if not at all times. All right, this right here is the null coalescing operator. This says if quantity has a value, use it. If it doesn't have a value, set -1 equal to quantity. It is similar to, but not identical to, the question mark colon operator. All right, the ternary operator. But here this is saying set quantity, that quantity right there, equal, assign it to QTY unless it's null. If it's null, assign -1 to QTY. And that's what they say in here. You can take a look at it yourselves. Now this becomes even more important in the AWD 1115 class that you take for the semester, because you oftentimes want to work with nulls, with numbers in ASP.NET, especially when you bring databases into the fold. All right. Says how to enable nullable reference types. You used to do it like this. All right, now you're basically going to be doing it more like this. Now notice it says, when do you want warnings displayed? When you assign or pass a null value to a non-nullable reference type. Well, as they mention here, prior to version 6, reference type could contain null values by default. If that wasn't what you wanted, you could enable nullable reference types. With .NET 6 and later, all project templates enable nullable reference types by default. So you can use that question mark. All right, the chapter ends then by going over, as mentioned here, 2 versions of this invoice total app. We've got the one version that we've already looked at in here. I built that for you. We built it in chapter 2. We put the code in chapter 3. So we've already got this, and I don't know if there's anything that's in there. Now, the way that I did it isn't set up exactly the way they did it in the book, but it's very, very, very similar. All right, and in here, they're just putting a discount percent of 25% for everybody, it looks like. All right, then they enhance it. And when we look in here, what are we doing? What's different? Well, we're adding what's called here a counter that has our total number of invoices. We're also adding here what's called an accumulator, which is going to add up the invoices. Plus, once we take the total of our invoices and divide it by the number of our invoices, we get an average. All right. So let's go in and take a look at that. All right. We've already got that example in here someplace, and I believe it's the other program. So let me do a file, save all in here, and let me bring up the other one. All right. I think it's here. And let's see if we can make these changes. All right. So what am I going to do here? Well, the first thing I'm going to do is I'm going to unlock my controls. Why? Because I want to take this and make it wider. All right, I'm going to take this and cut it down a bit. Whoops, not there. Cut it down to about there. That looks, maybe even a little more. Looks about right. Now, I'm going to grab this, copy it, and I'm going to paste it over here. Try it again. Paste it over. Oh, give me a break, would you? Control C to copy, Control V to paste. There we go. Why? Why am I doing this? Well, according to our book here, we now want it to say number of invoices, total number of invoices, and average of invoices. So it looks like also like this is going to have to come down a little bit because it looks like we now have 5 things in here and not 4 anymore. So let's bring this and this in. I'll give this just a little bit of room here. There we go. All right, so what do we have here? Let's just take a look. We move this down. All right, it says enter subtotal, discount percent, etc. It's got everything in there. I don't know what this enter subtotal is doing. So let's see. Let's not use what they have here because I don't know what that's supposed to be. But we will go and make some changes in here. All right, I'm going to remove this. And we'll bring this one back up. All right, and we're going to have 3 things here. So I'm going to get rid of this. Okay, and I'm going to go in and add this 3 times. Let's see, we'll make this smaller. We'll bring this over. And we'll bring this over. There we go. Now, what these are going to be right here are all of 3 of those are going to be read-only fields. So let's go over to the read-only and set that to true. All right, and then as far as what else is here, we've got number of invoices. So that will be number of invoices. So number of invoices. All right, and it looks like I didn't make that wide enough, so we'll widen that out in a minute. Total of invoices. And average invoice. All right, so those are okay. All right, let me move this over just a little bit and see if we can make enough room. There we go. All right, So let me change the names here. In fact, let me move this over so I've got some room to work with. All right. So this is going to be changed to LBL number of invoices, which means that the associated text box right here is going to be TXT number of invoices. This right here will be LBL total of invoices, which means that this will be TXT total of invoices. And finally, this will be LBL average invoice. And this will be TXT average invoice. Okay, so I think we've got all that stuff done. Let's go back and relock this up. All right. And let's see, I'm going to unlock this one because it looks like it's not lined up very well. There we go. Again, lock control. There we are. All right. I can, if I want to, and I don't have to do this, but I can move these over to center them a little bit more. Maybe that looks a little nicer. And then lock those back up. I think everything else should be locked. Now, I'm going to go back in. I don't have to do this, but I'm going to go back in and view my tab order again. All right, that's 0, 1, 2, 3, 4, 5, 6. So I'm going to keep it like that. 0, 1, 2, 3, 4, 5, 6. But now these are going to be 7, 8, 9, 10, 11, 12, 13. You really don't have to set the tab order for a label, but there we go. So view tab order. So that's done. All right, let's just, it's not working right now, but I just want to see what it looks like. Okay, it's not terrible. It's not a terrible interface. All right, but what are we going to need here? Well, in calculate, all right, we are going to need to add in calculate, we are going to need to add number of invoices, total of invoices, and average invoice. All right, so I'm going to add those three variables in here in my calculate. All right, and this is going to be an int, and we're going to call it number of invoices, and I'll set that equal to 0. In fact, I'm going to do for the first time, I'm going to come in here and I'm going to make that global, all right, by defining it outside of anything else. So number of invoices is going to be 0. I'm going to have a decimal. Total invoice, I'm going to call it dollar total. Set that equal to 0M. And then finally, I'm going to have another decimal in here that is going to be called average invoice amount, AMT. And I'm going to make that equal to 0M. All right, so I've come in here and created, let's be UN, we'll make that amount. So I now have these three variables: number of invoices, invoice dollar total, and average invoice amount. Well, with this number of invoices, all right, if I know that the invoice was, if it didn't work, I don't want to add it, so I don't add it here. I don't add it if it was empty. I don't add it if it couldn't be parsed. But if I get down to here, then I can come in and say plus number of invoices, because I do have a valid invoice now. All right, and I might as well, oh, wait a minute, that's for out of range, so I don't want to do it there. I apologize. That's under the last else. There we are. All right, so I've now got the number of invoices, and now I can say txt number of invoices dot text equals number of invoices dot toString. That one should work. So let's see. So file, save all, and it should only be adding these if we have a valid invoice. So we'll put in here 500. There's our number of invoices. But if we come in and put, if I clear and I put a negative value in here, it doesn't add one. If I leave it blank, it doesn't add one. If I put in something non-numeric, it doesn't add one. So that's good. All right. So we also want to take the amount of the invoice after we figure it out. So this will do the number of invoices. But after we have figured out the total right here, we can now also do a txt total. What do we call that? In fact, why don't we just do this down here? We'll move this down. All right. So that'll do our number of invoices. So we've got that. Then the next thing to do that's in here will be this, which is our total of all invoices, which is called txt total of invoices. So txt total of invoices plus equals our txt total dot text dot, well, let's see. I want to add that to this. So first of all, that's going to be dot text. Yeah, equals plus equals this. Yeah, that'll work. All right. And then we want to say txt total invoices. I don't want this. What do we call that variable up here? We called, this was number of invoices. This was invoice dollar total. That's what we want to be working with in here. So invoice dollar total plus equal txt total dot text. So we'll say here dot toString, and we will make that a number with 2 decimal places. We only want 1 period there. All right, txt total dot text dot toString n2. Okay, what doesn't it like here? Well, we're going to get this to work in a minute. So this will be txt total of invoices dot text equals this invoice dollar total dot toString. We want that to be currency. That worked. Why didn't this work? All right, we want to add to that. Where are we figuring this out? Total. That should be total. All right. So that'll fix those two. And now we can come in and say txt average invoice.text equals our total divided by our number of invoices. Okay, we want to do this whole thing. And then we want to convert it like that. Let's just take a look and see if it works. All right, and when you're testing this stuff, test it with simple values. All right, so 100. Okay, it was 90. We've got 1. The total was 90, and our average was 90. That worked. All right, let's clear, and let's try 1,000. We've got 2, 800. 800 plus 90 is 890. 890 divided by 2, that is wrong. So that calculation is incorrect. The reason that it's incorrect is we are taking total and dividing it by number of invoices. So for whatever reason, total, which should have been a decimal, and it is, and number of invoices was an int, but that still shouldn't matter. Why is it giving me that? Total divided by this, dot toString. Well, number of invoices should be a whole number, because it is. It's the number of invoices that we had. So that should be an int. But what I can do here, for whatever reason, it doesn't like this divided by this. I'm going to cast that as a decimal. See if that fixes it. All right, 100. Okay, that's correct. 1,000. This is still wrong. The average is wrong. Wait a minute. It's 100 plus 800, which would be 100. 800 plus 90, that is correct. But this is handling this as though it's an int divided by an int. I'm trying to figure out right now why. All right, so let's see if we can figure that out. This should be 445, because that's 890 divided by 2. Well, we did have a thing here that was called average invoice amount. So let's come in and do that and say that average invoice amount equals total, and that's a decimal, divided by number of invoices. Okay, that should be okay. And then the text there should be the average invoice amount toString. Okay, hopefully you're starting to see why we use variables. Again, we will go over all this stuff in a lot of depth and breadth of coverage. So 100, it's correct. 1,000. Okay, it's still, the average is wrong. Everything else in here is right, but this is wrong. The average invoice is not being calculated correctly. So let's do this. This will actually get to show you some debugging. All right. So I'm going to set a breakpoint right there and run the program. It's going to stop when it gets there. And I can check and I can see that my total was 90, and this is 1. So 90 divided by 1 gives us 90. All right, and let's keep going. So let's do it again with 1,000. And you can see, again, in here, that's 800. That's 2. 800 divided by 2, 1,000. It'll give me 20% off. Maybe this is right. Let's look at it again. We stop the breakpoint here. No, I think it's wrong. 100. All right, 90, 90. That's correct. It's dividing this by total. It should be dividing it by total of invoices. So that's the problem. It's not total here. It's the total. It's that. It's the invoice dollar total there, divided by the number of invoices. That should be correct. So 100, 1,000. There we got 445. Okay, clear. That's all working now. All right. So we made our own little copy here. You're going to get all this code. Don't worry about it. All right. So we made our own version of this enhanced one. Okay. That should be it for this chapter. When I come back in a couple minutes, I'm going to go over chapter 5, which is how to code control structures. We will talk about if statements and loops, and even though it's not talked about in this chapter, I'm going to show you the switch statement as well. All right? So I will come back and go over that chapter in just a couple minutes.